Hello, everybody. Welcome to Minding the Brain. Today we have a Q&A episode where we're going to be answering some questions from our audience. And if you have questions, you can go to our website and send an email, and your question might end up on a future Q&A. Our first one that we're going to do is from Lance, who asks, is dopamine addiction real? And further to that, can dopamine detoxes be helpful? Kim?
Yeah. So, Lance, I'm so glad you asked this question because it's funny. I actually posted something on one of my Instagram story this weekend because as I was kind of scrolling, as one does, something came up advertising the importance of managing your dopamine addiction. And I screenshotted it and I reposted it to my feed with the statement, dopamine addiction is not real. So I just have sort of addressed this. And in fact, our friend Darren McKee messaged me, Jim, and was like, well, tell me more, because he disagreed with me somewhat, I think. Because my argument is so it's somewhat of a semantic argument and somewhat of an academic argument. So on the semantic side, I would argue you are not addicted to dopamine. You are addicted to the thing that led to the dopamine. Does that make sense? So if you're addicted to cocaine, what's happening is you've had a loss of control over your ability to seek out and use cocaine. If you're addicted to alcohol, you're addicted to alcohol. If you're addicted to food, it's food. What happens as a result of you consuming cocaine or food or engaging in gambling is, yes, you do initially get a big rush of dopamine. And this is why people initially start taking substances or do things that end up leading to addictions, is because it makes them feel good, period. But that's not what you're addicted to. Do you see that semantic argument, Jim? Like it's the precedent, not the consequent.
So I think what you're saying is, like, in a sense, all addictions downstream have some dopamine relevance, but it's not. We don't want to say that it's the dopamine you're addicted to. Well, let me just follow up on that though, Kim, because somebody might say, well, maybe it's really the dopamine you're addicted to. I think if that were true, then if you were addicted to gambling, then alcohol might help or you know what I mean? It would be replaceable with something else that provided dopamine, but that's not true, right?
Well, sometimes it is actually. It is the case that you might go into recovery for your gambling addiction and develop an alcohol addiction. Yes. But here's my other point, and this is one that is much more of an academic argument, is the reality is dopamine is not involved in the later stages of addiction. Dopamine is involved in the initial binge intoxication stages of addiction, where, yes, it is the case that initially when we consume or engage in these behaviors, consume substances, engage in behaviors, you get this dopamine rush. But what is truly the addiction is not about dopamine. And that's what scientists now recognize, that it's more, even pleasure involves more of the endocannabinoids and the opioids. And the loss of control over the behavior is due to frontal cortical glutamate projections that actively inhibit those lower brain regions that are involved in impulsive behaviors. So I would say that it's also a very nuanced argument that it's not just about dopamine. And then to add to that, dopamine is involved in all kinds of things outside of reward. It's also involved in motor activity. So to say you're addicted to dopamine is a silly statement, because dopamine also is released when you're learning about fearful events, when you're taking a walk around the neighborhood. So do you see I kind of can see why this notion has been advanced and why that argument is, you're chasing that rush, which is ultimately dopamine. But at the end of the day, as a neuroscientist who is an addiction specialist, dopamine is just one part of the puzzle. And in the same way, dopamine detoxes. Well, if you did a dopamine detox, that's the equivalent of having Parkinson's disease. You have no dopamine, you're not moving. Is it good and helpful to disengage with things that can be addictive? So even our screens, and to go back with nature and to do things that don't cause that rush, for sure. But to call it a dopamine detox, I think is it bothers me as a scientist, as a neuroscientist, because it fails to understand the complexity of the nervous system as well as the complexity of reward behaviors that are targeting reward.
And I think if we could, if I could sort of read into Lance's question, I believe that someone would only ask these questions in the context of like, infinite scrolling apps, right?
Yeah.
And so, but that would be a different question. But like, can you be addicted to social media? Can you is it good to detox from social media? And that would be a sensible question. But like, but dopamine, since it underlies so much, that's not the right way to look at it.
Yeah. So agree with the idea in principle, but using the appropriate language is key.
I mean, while we're on it though, Kim, you want to answer, can you be addicted, like really addicted to social media?
Well, that's what my PhD student, Holly Shannon, is exploring. So we're trying to use the framework of what we know when it comes to substance use disorders. Recognizing that there are key brain structures that are implicated. There's a very real clinical syndrome that we see with substance use disorders. And also that meeting that definition of loss of control over reward-seeking behavior. And definitely we do see that some people, quote unquote, lose control over their ability to engage with social media. And then Holly, my PhD student, is definitely looking at the areas of the brain that we know. For example, we see with addictions, you get changes in the structure and function of the nucleus accumbens. And yes, we do see this that's associated with problematic social media use. We also see changes in the frontal cortex. They're not nearly as significant as what you would see with things like opioid addictions or cocaine or even alcohol. But there's something there, and it is definitely targeting the similar systems in the brain that we know are implicated in substance use disorders.
All right, that is a great complete answer for Lance, and we look forward to Holly's results. Okay, so let's go to our next question, which is from Ava. She says, I've heard that there's a link between psychedelic drugs and schizophrenia. How can you tell whether it's safe for someone to use psychedelic drugs?
So let's answer the first part. So the link between psychedelic substances and schizophrenia. I think what we do know, Eva, is that there is a link between cannabis and schizophrenia. For sure, this is a well-established, very rigorous outcome. We know this is what's called an epigenetic finding, that there's some people who have a specific copy of a gene coupled with high dose THC, so that's like THC, cannabis products that are very high in THC content, that you're using that daily or near daily, under the age of 16, typically male. This has very much a well-established link with the onset of psychotic disorders, including schizophrenia. But what you're asking about is psychedelic substances. And some people might actually classify cannabis as a psychedelic substance. I personally do not. I think what you're referring to are things like mushrooms and potentially other psychedelic agents like LSD. And there isn't that link that I know of for sure, that is that strong link that we know with cannabis. That said, there are people who do consume acid or LSD that have something called hallucinogen persistent flashback disorder, which means that even after your last acid trip, say it was in 1985 or 2002, they can have a flashback of that acid trip, much longer past that initial acute use. So that can be considered some version of a psychotic disorder, although that's not how it's classified in the Diagnostic and Statistical Manual of Mental Disorders. So that's what we know of. It's a bit of an answer, but maybe not. And then the second part was, how can you tell whether or not it's safe to use psychedelics? That's the challenge. Frankly, we do know that there are certain genes that are associated with more detrimental outcomes of taking some substances. But the reality is there's no quick way to know that. Things like companies like 23andMe, which have since, I think, collapsed. Yeah. It's not reliable, it's not rigorous, and it certainly isn't cheap to be able to find out that information. So for now, I would say the red flags, if you are concerned for your own use or for a loved one who's using, What we do know that can increase the likelihood of you developing significant mental health challenges following substance use is if you or your family member has a history of a psychiatric disorder. So say if mom or dad have schizophrenia, or if mom or dad have severe depression or anxiety disorders, or you have that, you are at a greater risk of developing a mental health disorder as a result of your substance use or your friend or whoever it is that you might be asking. So thanks for asking about safe substance use. So Jim, I'm going to turn it over to you. Is it true, Liam is wondering, is it true that neuroscience disproves the idea of free will, or are people misrepresenting the research? And I know this is a neuroscience question, but I'm pinging it to Jim because he's my free will man. And he knows more.
Yeah. So there's this strange tendency that people have, is that when they hear about some way that the brain does something, they immediately dissociate from it, right? So it's this "my brain made me do it" kind of idea. And once we know that the brain, or even a brain area, is implicated in some kind of decision making or mental act, we give people less blame. We tend to think that the person is sort of out of control of it. People automatically think it's genetic. They automatically think it's unchanging, and all of these things are misunderstandings of how the mind works. Every experience you have changes your brain, and we might know that in the abstract, but the brain is far from a static, genetically determined organ. Now, what's also strange about this idea that we have, that if we can find a way the brain does it, then it's not us and we're not in control, is that we know that the brain is always doing something. Like, even when we're completely clueless about how our minds are doing something from a neuroscience perspective, we know that the brain is doing something. We just don't know exactly what it is. So, it's not really, it doesn't really make any sense to say that we're in control for those areas for which we're ignorant, right? That's kind of a silly thing. Now, what about free will specifically? Well, free will is really not very well defined. Okay, some people think it means counter-causal, like it's counter to the causal structure of the universe or whatever. People, when you press them on what do you actually mean by free will, they actually have a lot of trouble saying what it is. And when you're in a situation like that, science really can't go very far. We have a very poorly defined concept. It's very challenging to know whether a certain neuroscience finding does or does not contradict it. So if you were to make a more specific idea, well, what I mean by free will is this, then science can say, well, is this happening, right? And then we can do that. So just not to say that this is the definition of free will, but let's imagine that we have a version of free will, maybe, that is when an agent makes a choice between multiple options. Okay, multiple options are considered and one is selected. Okay, and that might even be in a very deterministic system, like it's just sort of like clockwork in the universe. But still, if it considers more than one option, then it's done. Then we can look at neuroscience and we can and psychology, and we can apply its methods to determining whether that's happening. So, for example, if you have a reflex action, like when you they tap your knee with a hammer and your leg goes out, that is a behavioral response that just comes directly from the spinal cord, and the spinal cord is not considering, what do I do? Should I say something? Should I do something? No. It's a very like direct, like neural connection that doesn't actually weigh options and consider other things. So we would say that is not an act of free will. Okay. Mm-hmm. If you are sitting there pondering which university to go to, or what to major in, or who to marry, or whatever, and when you're thinking about like the pros and cons of this or that, and you're wrestling with it, then obviously that is a clear instance of choosing an option amongst many by considering, and then you would say it is free will. Now, I understand while I'm saying this, that most people aren't going to find this very satisfying, okay? Yeah. Because when they think about free will, it's got some sort of the amorphous mystery of it is part of the allure of the question. But that very mystery and allure is what makes it not scientific and endlessly argued by people in dorm rooms. So, dorm
rooms and not classrooms.
Yeah, it does get discussed in classrooms, and I can say that, like in academic philosophy, it is still a very hot topic that is still debated. So, anyway, we go into a much deeper dive with this in our podcast on episode 44 on free will. So, thanks for asking, Liam. All right, let's talk some more about cannabis. So Olivia wants to know, should you wait until you're 25 to try cannabis? Is it safe? Is cannabis safe for older adults but not younger adults? What is the relationship between age and cannabis, Kim?
So this is another great question, and it's awesome to hear that people are really concerned about the harms and risks associated with cannabis use. So the first thing about the when you should initiate cannabis use, and is 25 an okay age? Well, I want to start out by saying the reason why we have minimum age requirements for legal substances, so things like alcohol, nicotine, and now cannabis, is because in the addiction research field, we know that the age of initiation, so the younger you are, the more that correlates or relates to problematic use, right? So if you initiate substance use age of 12, 13, 14, it tends to be that you're more likely to have an addiction, and you're also more likely to experience harms. Why is that? Well, very simply, the brain is still developing when we're an adolescent. And we know the brain develops all the way up until probably early adulthood, which is debatable, but around the age of 28 or 29. Now, depending on what province you live in, cannabis is either legal for you to consume beginning the age of 18 or beginning the age of 19. And that age was selected based on some evidence that shows, again, similar to alcohol, that this is around the time that most of those brain regions that are involved in decision-making and reward activity tend to be completed. I say tend to be because emerging evidence now suggests that we know that the brain isn't really fully completed development until that age of around 28, 29. It depends on your gender, it depends on experience, depends on a whole host of other things. So the answer to, is it safe, should we wait till 25, is if that's the age that you feel you're less risk for harm, fine, because yes, 25 is older than 19 and 18, which again, is still in that magic developmental window where the brain is not fully completed development. But it's a kind of arbitrary number, 25, not going to lie. I think the later you start, the better it is. But also there are those individual differences that you should be mindful of. So as I was just talking about earlier, do you have a psychiatric diagnosis of a psychiatric disorder? Do you have a family member of a diagnosis of a psychiatric disorder? Have you also experienced early life trauma, so traumatic events, which we know sets up the brain quite differently for vulnerability later in life? So those individual factors should also be guiding you in terms of your decision making, in addition to your age. As for older adults, it's a completely different issue. Older adults relates more to toxicity and more to the metabolism of the drug in the body. So as we age, we produce less of those enzymes, or the functionality of the metabolic systems in the body are in decline. That's why we have to be very cautious with any dosing that we give to older adults, regardless of the substance. If it's a pharmaceutical or non-pharmaceutical substance, you have to be mindful of toxicity. And that, for the same reason, now emerging data is showing that older adults experience some more negative side effects from taking cannabis products, in part because they're metabolizing it a lot slower. So they may be more at risk for overconsumption, and then you kind of feel like really spaced out, you green out, you vomit if you've taken too much cannabis. So whether or not it's safe, again, it depends on all those individual factors, but also safety is a funny thing with substances. We tend to think about safety in terms of overdose risk. Cannabis is not a substance that you can overdose and die from, but there are other negative side effects or harms that are associated with cannabis. So younger age, more at risk for things like dependence, addiction. Older age, more at risk for perhaps drug interactions or feeling really nasty if you take too much, accidentally take too much of the substance.
There's no quick way to know whether you're done developing, though, right?
No, and that's you can't go into a brain scanner and go, whoop, okay, frontal lobe, totally
She's done.
Yeah.
Give her the cannabis.
Don't we wish. So back to you, Jim. We're going to ask questions about language. There's always a lot of curiosity around bilingualism and learning languages. So Emma is wondering, if you learn 2 languages as a child, does it make you worse at both of them?
Yeah. So It turns out, no. The answer is no. Children with two native languages learn both equally well, and studies show they are just as fast as if they were learning only one of them. What we have are slight vocabulary delays, but the overall language skills are unaffected. And most research finds that bilingualism enhances your life in various ways. Better cognitive control, might even delay dementia for as long as 4 or 5 years. There is some work, I think some of it happening at Carleton, where we're looking at some of the negative effects of bilingualism because there's no free lunch. I can relate it to learning how to read actually makes you worse at facial recognition. So the part of your brain it's not natural to read. So it has to, the brain recruits some part to do it. And people who are illiterate actually are a little bit better at facial recognition. So generally, being native at two languages. Now the question was very specific, learning two languages as a child. Now I assume that means they're both like mother tongues. When you study languages, of course, after, what we might consider the critical age of learning languages, of course, it's much slower, as everyone who's studied languages, past puberty knows.
As somebody who is bilingual, je parle les deux langues. I've always thought it's been fascinating to know whether or not that's helped or hindered. And I would argue my vocabulary in English is actually very, very good, whereas my vocabulary in French is less so. Okay, here's one for both of us, Jim. Noah's wondering, what are the similarities and differences between the fields of cognitive science and neuroscience?
Okay, I'll start with this, and I'm curious to hear if Kim has anything to add. So cognitive science is a relatively small field, and it focuses on understanding how minds work, particularly from what we call an information processing perspective. What is information processing? It's kind of the way that we talk about how software works. So there are mental representations. How do they get created and manipulated? Things like belief and desires and emotions and this kind of thing. How do they interact in a way that causes you to behave the way you do and think that the way you do? And so most of cognitive science is kind of obsessed with understanding how minds work at that level. And it's not the only level that there is. And it's also importantly multidisciplinary. So we have psychologists and philosophers and computer scientists and neuroscientists. So neuroscience is considered to be a part of cognitive science, but generally speaking, cognitive scientists are only interested in the neuroscience to the extent that it informs this kind of information processing level. Neuroscience, on the other hand, is much more biological. It's much more focused on the physical implementation of thinking, and often doesn't even talk about the higher level sort of representations and information processing that cognitive scientists focus on. And many neuroscientists, they study, ion channels and very, very low level biological things. And they're not, in their day-to-day life, not particularly concerned with tying that to what we normally call thinking day to day.
Yeah, I think that's an excellent summary. I always think of like cognitive science is more, it's like the study of those cognitive domains. So things like thinking, language, reasoning, memory. And it's not that neuroscientists don't study those things. It's just we might be, as you said, more interested in understanding what's the mechanism of how we learn, right? So like what cells are involved, what circuits are involved, what ion channels are opened, what neurotransmitters, what happens if we do like lesion or get rid of one of those areas. And to that end, I would say our tools might differ slightly in how we're interested in investigating those questions. So I would think about cognitive scientists as using things like imaging, and a lot of studies of manipulation with humans primarily, although there are some animal cognitive scientists, right? That use but there is, definitely a degree of overlap. And I would say a cognitive scientist would find a home in a department of neuroscience, and a neuroscientist would find a home in a department of cognitive science. It's really, I think every institution tends to split us up in different ways, right? So we have here at Carleton, we have both the Department of Cognitive Science and we also have a Department of Neuroscience, but that's unusual. They tend to be sometimes housed under one big Department of Psychology, for example.
Yeah, and I will say that the Department of Neuroscience and Cognitive Science are the only ones in Canada at Carleton.
Boom!